Alright, just like with any problem, there are multiple ways you can answer number 10. The question is, which statement about f of x equals 2x squared minus 3x minus 5 is true? So the way that I'm going to show you right now, or reiterate to you, is to look at the answer choices and use the answer choices to help guide you to figure out which way is the best way to solve the problem. So you can look here, all of these have different solution sets. This is negative 5 halves and negative 1, negative 5 halves and positive 1, negative 1 and positive 5 halves, 1 and 5 halves. So we could find the solutions on the calculator. The problem with that is that if we have negative 5 halves or positive 5 halves, that's not going to show in the table because the table doesn't look for fractions. It only looks for when x equals a whole number. So that's going to be less helpful to us. Over here we have different factors. X plus 1 and 2x plus 5, x minus 1 and 2x plus 5, x plus 1, 2x minus 5, x minus 1, 2x minus 5. So these are each different varying sets of factors with pluses and minuses switched out. So what this means is that this should factor to one of these pairs. Now, since we got pretty good at factoring, I'm going to use that method, and then we're going to check it using the calculator. Now, is this already set up where we have A, B, and C? Sure is. So A equals, B equals, C equals. A is 2, B is negative 3, C is negative 5. We are going to use the bottoms up method to figure out what these values are. Remember, on the top, A times C, on the bottom is B. So 2 times negative 5 is negative 10, B is negative 3. We're going to use the calculator method that we learned earlier, which is to say we're going to take that top number at the top, negative 10, divided by x. On the second line, we're going to do the same thing. We're going to add x at the end, and then go to look at what numbers add up to negative 3. So I'm looking for negative 3 in the far right column. There it is. It's 2 and negative 5. So I have 2, and I have negative 5. Now, using the bottoms up methods means that I'm going to divide each of those factors by this number. See if either one of them reduces. 2 over 2 does, reduces to 1 over 1. Negative 5 over 2 does not. Now, this is going to create our two factors. One is going to come from 1 over 1. The other will come from negative 5 over 2. Using bottoms up, that means bottom goes to the front, top goes to the other side, x plus 1. Now, this has an x minus 1, this has an x minus 1, so B and D are out. For the other one, bottom goes to the front, that's 2x. Top goes to the end, negative 5. 2x minus 5 is your answer, letter C. Number 11 says, your new electric car's value depreciates by 6% annually. If you paid to $24,500 for your car, what exponential function could be used to represent the value of your car as it depreciates every year? Now, we're talking about depreciation, we're talking percentages, we're talking initial values, which means at the star means we're going to go to our formulas relating to exponential equations. This is a growth or decay, which is A equals 1 plus or minus r to the power of x. Since we're talking about the value of the car and it depreciating, this is going to be a decay situation, which means we're going to be using the minus. Now we need to find out what A is and what R is. Again, if we go back to our formula chart, A is the initial value, which in this case was the $24,500 we paid for it. Okay, then we're going to go with R. R is 6%. But remember, we're going to find that number as a decimal. 6 divided by 100 is 0.06. We're going to plug this number into this formula. So it becomes 24,500 times 1 minus 0.06 to the power of x. Now that 24,500 at the beginning automatically eliminates letters C and D because they just had 245. Okay, my next step here is to simplify what's inside there. So I'm going to say 1 minus 0.06 equals 0.94. So it'll be 24,500 times 0.94 to the power of x, which is letter B. On to the last couple of problems. Number 12 says, the graph below shows the change in value of a car over several years. Based on the information in the graph, which conclusion appears to be true? All right, the car lost about 1/2 its value every 3 years. Okay, so let's see. From year 0 to year 1, or to year 3, let's say. So that's going to be right about here. If it was initially worth 12 and now it's worth 6, that's half. Okay, so from this to year 6, it should be down to 3, which it is not quite. Okay, at year 6, it's here a little bit above 4, so that's out. Okay. Letter B says the car lost 1/4 of its value every year. So that means if it starts at 12, 12 times 1/4, or 1/4 of 12, 12 divided by 4, is 3. So we're going to say 12 minus 3. Should be down to 9 after year 1. It's about 8.5 after year 1. So that's not quite right. So B is out as well. The car lost less of its value between years 9 and 10 than between years 1 and 2. Well, here's 9 and 10, and it didn't look like it changed much at all. It's less than $1,000, but between years 1 and 2, it did drop quite a bit. Okay, so C is going to be our correct answer. The longer you wait, the less value it loses every year. It's still losing value, but it's losing it much slower. Number 13, an adult takes 400 milligrams of aspirin. Each hour, the amount of aspirin in a person's system decreases by about 20%. Which of the following is an exponential graph that represents the situation? Well, if we look at this, it's a decay situation because it says it decreases. It also says that it starts at 400 milligrams, which means that our graph should start at 400. If we look here, this one, it's hard to read graph, but this is 50, 100, 150, 200, 253, 300, 350, 400. This starts at 400. That's a possibility. Okay. Here's 400, but this is way over here. That's out. Here it shows the value or the amount of aspirin increasing. That's also out. Here it shows negative time. Again, no negative x values are going to happen for these situation graphs, so D is out. A is the only graph that makes sense. And we didn't even have to actually graph it. So there you have it, your entire review. Good luck on the final.